Okay, I'm back to solve some more equations with you today. This time they're going to be variables on both sides. So when there's variables on both sides, my tip to you is try to get all your variables on one side of the equation if it's possible. So like if there's only one variable like x in the equation, try to cancel them out from one side so you only have them on one side and then we'll solve it. So let's start out with a problem that's geometry related. Okay, it says the measure of an angle is 5x minus 3 degrees. Okay, its vertical angle has a measure of 2x plus 12 degrees. Find the value of x and the measure of each angle. And there's a hint here, vertical angles are congruent. So there's a lot of vocab in here that you might not know. Vertical angles, they'd be angles kind of like this. Okay, looking like that. If two lines intersect, they're across from each other. And congruent just means they're the same size. So one of these we could call 5x minus 3. The other one we could call 2x plus 12. And I know that they're congruent, so that means they're equal. So I'm going to set up an equation like this. 5x minus 3 equals 2x plus 12. Okay, and my job is to solve this equation, and I need to keep all the rules I've learned before, do the same thing to both sides, etc. So I like to try to get all my variables to one side first, so I try to eliminate them from one side. So this time I'm going to try to eliminate the 2x from the right side. I'm going to do that by taking away 2x from both sides. It's important to include your x there. Okay, on the left side we have 5x minus 2x minus 3, so I can combine my like terms. 5x minus 2x is 3x. I still have that minus 3 there. On the right, 2x minus 2x, it cancels each other out, and I just have 12. Okay, this looks like your generic two-step equation, and by now you should know that I just need to add 3 to both sides, and I get 3x equals 15. I can solve it by dividing by 3, and I get that x equals 5. Okay, notice that this is a word problem, and I need to go back and make sure I solve both parts of the problem. So in this problem it says, find the value of x, which we did, and find the measure of each angle. So we need to take our x value, which we said was 5, and plug it in. We have 5 times 5 minus 3. That gives me 25 minus 3, so I think this angle is 22 degrees. Okay. And this angle says 2 times 5, 2x, plus 12. So I get 10 plus 12, and lo and behold, I believe that that is also 22 degrees. And since vertical angles are supposed to be congruent, it better be 22 degrees each. They better match, or I probably did something wrong. All right, another word problem for you. You can buy a skateboard from a friend for $60 and rent the safety equipment for $1.50 an hour, or you can rent all the items you need for $5.50 an hour. For how many hours must you use the skateboard to justify buying your friend's skateboard? So in other words, you don't want to pay more than you need to. So if you're going to rent for a lot, this might be a good idea. If you don't rent much, it would be a bad idea. So the variable we're looking for is the number of hours, so I'm going to call that h. H, the number of hours that I rent the equipment, or number of hours that I ride. Okay. So if I buy from a friend, I have to pay $60 and, so plus, $1.50 an hour. So 60 plus 150h. I want to know when that's going to be equal to just renting for $5.50 per hour. So my equation here would be set up 60 plus 150h equals 550h. I've got variables on one side, so I want to choose to eliminate one of them. I recommend choosing to eliminate the 150h. So I'm going to subtract 150h from both sides. And I'm going to be left with 60 on the left equals 4h. Okay, and now I can just divide by 4 both sides, and I get h equals 15. Okay, so 15, in this word problem, that means 15 hours. At 15 hours, these are both going to cost the same. After 15 hours, then it gets cheaper to rent from your friend, or to buy it from your friend and then just rent the cheap stuff. So I'm going to say at least 15 hours. If you don't skateboard that long, it's not worth buying it. But if you skateboard for at least 15 hours, hey, go for it. Okay, Sometimes in math you encounter some of these kind of tricky, weird equations that I like to call identities. You might think of identity as who you are, something that doesn't change. Your identity is you. An identity in math is an equation that is true for every single value of the variable. For example, 3x equals 3x, that's an identity. No matter what you pick for x, so say x is 5, 3 times 5 equals 3 times 5. Yeah, 15 equals 15. Say you pick negative a third. 3 times negative a third equals 3 times negative a third. Yeah, negative 1 equals negative 1. That works no matter what you pick for x. So x could be any real number. That's called an identity. Sometimes you have an equation that's actually never true. If an equation is never true for any value at all of the variable, we call that an equation with no solution. And I'm going to show you some examples of that too. So we're going to work with both of these tricky special equations today. Okay, so we're going to solve some of these equations. I'm going to look at 4 minus 4y equals negative 2 times 2y minus 2. So I would probably try to simplify this equation first and use the distributive property. Negative 2 times 2y is negative 4y. Negative 2 times a minus 2 is a positive 4. You could say negative negative 4, but it's going to turn into plus 4. Equals 4 minus 4y. You might notice something already, but if you don't, we can try to eliminate the variables from both sides. So I'm going to get rid of this negative 4y by adding 4y to both sides. And then I get an equation that says this, 4 equals 4. Does 4 equal 4? Yes, 4 equals 4. It always equals 4, no matter what you're picking. That means no matter what you pick for y, it's going to work. So we call this an identity. That means all real numbers are solutions. Okay. All right, so you're gonna see some problems like this. Okay, let's look at this next one. Negative 6z plus 8 equals z plus 10 minus 7z. Okay, so again, I'm going to try to simplify as much as I can. It looks like this right side, I can combine z and negative 7z to make negative 6z. I have negative 6z plus 10 equals negative 6z plus 8. Okay, and I've got these negative 6z on both sides. To get rid of it, I'd add 6z. And you're going to notice something funky here. This is 8 on the left side, and on the right we just have 10. And we get an equation that looks like this, 8 equals 10. Think to yourself, is that true? No, 8 does not equal 10. It's never going to equal 10. 8 does not equal 10. This is called an equation with no solution. No matter what you pick for z, you're never going to get an answer that matches on each side. So here's the special little symbol. You can use the empty brackets like this, empty braces I guess you call them, to mean no solution. You can practice writing that. That's kind of fun. Okay? All right, so you're getting kind of bombarded with a lot to practice here. Let's look at one more thing, which is using a graphing calculator to solve an equation. Okay, so we're going to solve this equation, 4 plus 0.5x equals x minus 1, by using a graphing calculator. And I'm going to want you to check your work. So I will show you a method to do this on your graphing calculator, and we'll see if you get the hang of it. Okay, so I'm going to pull out my graphing calculator. I think you can see it fine. And what I'm going to do is I'm going to go to this y equals button here on the left. And I'm going to, well, if I can get it to work, we'll see how it goes. Okay, and you have a little practice with 7th grade from working on graphing your equations in a graphing calculator. What I'm going to do is I'm going to type each side of my equation into two different y parts. So y1, I'm going to type that as 4 plus 0.5x. Okay, so 4 plus 0.5. Oops, I got an extra little plus in there, so I'm going to have to delete that. Let's see if I can get it just to clear out. Okay, so 4 plus 0.5x. And then I want to look on the next one, I want x minus 1. Okay, so I'm going to do x minus 1. And I'm going to graph this I recommend that you use the standard viewing window to graph it at first and then see if you need to change it. So I'm going to hit zoom 6, which is zoom standard. It goes from -10 into 10 in all axes. Okay. What we're looking for here is when they're equal. So you can probably see is what I'm looking for is the place where these two intersect, which, looks like it's up here in this area somewhere. I am going to find out for sure. I'm going to do a calculation feature on my graphing calculator. So I go to second trace, which is second F4 right here. You see it says calc. Second trace. And you're going to see number 5 says intersect. So I'm going to push the number 5. And then I'm going to make a little guess of where it's going to be intersecting. So I might arrow over a little bit. Or I might not worry about that too much and just let the calculator do most of the work. And I'm going to have to hit enter, enter, and then guess. So enter 3 times. And it's going to get it for you if it sees a sign change on there. Mine did not see a sign change, and that's probably because my window wasn't big enough. So you might have that problem sometime again. So I'm going to change my viewing window. Right now it was only going from -10 to 10. It looked like to me that it was up in the top right. So I'm going to make my X value a little bigger, maybe 20. And I'm going to also make my Y max a little bigger, 20. And then I'm going to try again. Now I think I can see a little better in that new graph where it changes. So we'll hope that works if I try this again. I'm going to go second calc again. 5, which is intersect. I'm going to try enter, enter, enter. Okay, and now it looks like it can see where it is, and it looks like it's the point x equals 10, y equals 9. I'm going to go back to my screen and we'll think about this. Okay, so when I graphed these, it looked like they intersected here, like kind of over here at 10, 9. So you might want to think, in this case, the x value is 10 and the y value is 9. Okay, so I'm trying to solve for x, so it seems that x is 10. So I think x is 10 by using my graphing calculator. I'm going to check it by putting in 10 for x. So I'm going to do 4 plus 0.5 times 10. I want to know if that's equal to 10 minus 1. So I've got 4 plus 5. Is that equal to 9? Lo and behold, it is, which is not surprising. That's what I was supposed to get for y anyway. X equals 10 seems to be my answer using my graphing calculator. Okay, what I'm going to have you guys do is go back and try a bunch of problems on your own, and I might run out of time in the video to get these all like solved full out. So you try these ones on your own, and I'll at least put the answers in here. I'm going to try to work at breakneck pace, but we'll see. Okay, so you'd pause it. So this problem, distribute. I've got 7x plus 15 equals 7x plus 14. Hey, that sounds kind of suspicious. If I subtract 7x from both sides, I'm going to notice that it says 15 equals 14. That is not true. That's never true. 4a, that's an equation with no solution. Okay, 4b, if I try this one, I'm going to combine my like terms over here first. And -3 plus 8 is 5. So I've got 6x plus 5 equals 12x plus 5. I'm going to subtract 6x from both sides here. And I get 6x plus 5 equals 5. I'm going to subtract 5 from both sides, and I'm going to move over. Looks like I have 6x equals 0. If I divide both sides by 6 here, I get a solution of x equals 0. It's important to note here that x equals 0 is a solution. 0 works in that problem. Okay, let's try this one more real quick. Okay, add here, I get 12x minus 10 equals distribute. So here I've got 12x minus 8 minus 2. If I simplify that down, it's 12x minus 10 equals 12x minus 10. You're allowed to stop there if you want, because lo and behold, those are the exact same thing. So this is an identity. All real numbers work. Okay. Okay, and you might want to challenge yourself. I'd love it if you could do this before class tomorrow. But try to write your own equation that's an identity and your own equation that has no solution. If you can do that, you're going to be on a great track for this. Okay, good luck and see you tomorrow.